Alright, today we're going to be talking about our final notes of this unit, which is Unit 4, Note 7, where we're going to be using the zero product property, and we're also going to start about applications and word problems for all of this stuff that we've been doing. So first of all, the first most important thing you need to know is the zero product property. This is going to come into play a lot now when we're doing our factoring. Okay, so basically the premise behind it is that if A times B is equal to 0, then either A or B has to be equal to 0. This makes sense. In order to get something to multiply to 0, something has to be 0. So that's what we're saying. One of the two of them is going to be 0. So we're going to use this idea to actually solve for x. Before I talked about when you have x squareds in an equation, we can't solve it by just solving for x because we have a squared term. Well, that's what our factoring has been working towards, and that's what our goal is for today. So let's start off easy. Let's take a look at number 1. Excuse me. So we know that each of these factors needs to be set equal to 0, okay? Either one of them is going to be 0. So we're going to say x plus 6 is equal to 0, or x minus 4 is equal to 0. Okay, that's just using the product property. Either one of those is equal to 0. So what we're going to do is we're going to go ahead and solve that for x. I'm going to solve both of these equations for x. So then I get that x is equal to negative 6 and x is equal to 4. Okay. X is equal to negative 6 and x is equal to 4. Same thing for number 2. So for number 2, we're going to take 2x plus 8 is equal to 0, as well as 3x plus 2 is equal to 0. Again, just going to solve it for x. So I want to subtract 8 from both sides. 2x is equal to negative 8. Divide 2 from both sides, x is equal to negative 4. Let's take a look at that second one. Solving for x, we're going to subtract 2 from both sides. Then we get 3x is equal to negative 2. Divide both sides by 3. And you get x is equal to negative 2/3. Now I went through solving those equations really quickly. Okay, again, at this point I'm assuming solving equations is something you can do naturally. If it's not, please let me know. Okay, or rewatch the video a couple times to catch how I was solving those equations. Try and help yourself. So for that one, we get x is equal to negative 4 and negative 2/3. Go ahead and try 3 and 4. Use the same thing. You're setting both factors equal to 0, and then you're solving for x. I'm going to move on. So now these aren't set up. They're not factored for us. So if we want to use the zero product property to solve for x, we actually have to factor first. First, I notice the squared term here. Okay? There's no coefficient with the squared term. That means that a is equal to 1. The coefficient of our squared term is 1. So I can just set up the x and then write out what I get. So I have my product is 1 times negative 20, which is negative 20. And then I'm adding to 1. So things that multiply to negative 20 and add to 1 are positive 5 and negative 4. Again, negative sum means I have one of each sign. So now I'm going to sit out and write out the factors. So I have y plus 5 times y minus 4 is equal to 0. So I'm going to go ahead and I am going to set each of those factors equal to 0. Solving for y is equal to negative 5, and y is equal to 4. So these are my two answers. Y is equal to negative 5, and y is equal to 4. So I went through, factored, set each factor equal to 0, and then I solved for y. All right, let's go ahead and look at that second one. So I notice on this one right away that I don't have a is equal to 1. So remember, there's two methods, when a is equal to 1 and when a is not equal to 1. So I need to use the method when a is not equal to 1. So to set up my x, I'm going to multiply 6 times a negative 6, which is negative 36. And then I want it to add to 5. Okay, so negative 36 products that add to 5 are 9 and negative 4. So I'm hoping at this point again that you can set up these x's on your own. If you can't, please come in for help. Go to the Math Skills Center. Do something to get yourself the help that you need. So once I have these factors written out, because my a, that coefficient with the squared term, is not equal to 1, I have a different method that I need to use. I need to split up the middle b term as 9p minus 4p minus 6. Remember, it doesn't matter what order. Okay, now that I have 4 terms, I can go ahead and group things. Between 6 and 9, I can pull out a 3, and I can also factor out a p. And then I'm left with 2p plus 3. Out of that second group, I'm going to take a negative GCF, and then I'm going to take out a 2, and then I'm left with 2p plus 3. Remember, I took out a negative GCF, so that changes the signs. If you check, my leftovers here match, so I have 2p plus 3 times 3p minus 2. So this right here is factored form. Normally we stopped here. But now I need to go and I need to solve those factors, and I need to set them equal to 0. So I have 2p plus 3 is equal to 0, and 3p minus 2 is equal to 0. I don't know why I put those parentheses there. You don't really need them. So now I'm just going to go ahead and solve each of these for p. So again, this is solving equations. If that's something that's still confusing, please let me know. Over here, solving for p, and I get p is equal to 2/3. So p is equal to a negative 3/2, and p is equal to 2/3. Most of the time, you will have two answers. Starting next unit, we're going to talk a little bit more about what it means if you get the same answer. Okay, think about the times when you have a factor squared, where you had two factors multiplied by each other. If you set both those equal to 0, you get the same answer. It will happen, but most of the time you're going to get the same, two different answers. So I want you to go ahead and try 7 or 8 on your own. Remember, think about which method you need for factoring, and then go ahead and factor it. And then I want you to solve your factors using the zero product property right after that. Let's talk about some applications. Why have we been doing all of this crazy factoring business? Well, we've kind of talked about how factoring is leading us towards parabolas, and we're going to start graphing these next unit. Basically, here's kind of the design we're setting up with this problem here. So if you need to pause the video to read it, please do that. So flare is launched from sea level, which is right here. It's going to go up, and eventually gravity is going to take over, and it's going to start coming back down. So this point right here is representing when it hits that sea level again. Okay, so this quadratic, this h equals 100t minus 16t squared, represents this parabola that I just drew on the board. Okay, so this is kind of like our x-axis here, and then we have our y-axis here. Oops, so it should be a y. Okay, so we want to follow this path. So we're going to use x to represent time, okay, which is represented by t in this equation. So I just wanted to give you a graph so you can kind of visualize what we're working towards. So if h is equal to 0, that's our height. Our height is equal to 0. We want to solve this quadratic right here. So what we're going to do is I'm going to take 100t minus 16t squared, and I'm going to factor it. Notice that I only have two terms. Since I only have two terms, I have to use GCF. I can't use the x because I don't have three terms. To use the x, I have to have three terms. To use grouping, I have to have four terms. If I just have two terms, my only hope is to pull out a greatest common factor. Well, I can factor out a 4t out of this, and then I am left with 25 minus 4t is equal to 0. So now I'm going to set each of these factors equal to 0. Okay, so if you're still confused about how to take out the greatest common factor, again, please come talk to me in class. So, dividing everything by 4 to solve for t, we get t is equal to 0 seconds. First of all, that makes sense. When we first launch the flare, we're starting at the ground. Okay, the ground is a height of 0. Next, we're going to solve this one for t. So I'm going to subtract 25 from both sides. I get negative 4t is equal to a negative 25. Divide both sides by negative 4, and then that's actually going to come out via decimal. Since we're dealing with time, feel free to actually write the decimal instead of the fraction. So this is 6.25 seconds. So this right here was at 0 seconds. This right here is at 6.25 seconds. Well, let's look at what the question was asking us. It asked us how many seconds it will take for the flare to return to C. So the answer is 6.25 seconds. Okay, let's take a look at this next one. All right, so we're talking about a rugby field. Again, pause the video, take a second to read through the word problem. So let's draw this rugby field. We have a width W, and then the length is 52 more than the width. So this is kind of like that pasta box problem from our last test. So we know area is length times width. What I'm going to do to give us nicer numbers is I'm actually going to change our area to be 8,540. So I'm going to have the area equal to 8,540. Here's the mistake I see students make. First, they remember, okay, yes, I need to distribute this W in, and then I get W squared plus 52W is equal to 8,540. Many students are like, Ms. Humbert, why did you do that? Clearly, W is equal to 8,540, and W plus 52 is equal to 8,540. That's not the case. Okay, the zero product property only works if the factors are set equal to 0. If you look right now, I don't have that case. So I actually have to go through, subtract this from both sides to give me a quadratic. So when I do that, I end up with this. So now we want to go ahead and set up our x. So we're going to set that up. So I want to multiply to negative 8,540, and I want to add to 52. So this is one of those where you're really going to have to play around with numbers. So if you want to pause the video, see if you can figure out yourself, go ahead. I'm going to write the factors in. So we get negative 70 and 122. Because our a is equal to 1, we can go ahead and pull these factors out. Okay, some of you look at this and you're like, well, it's 70 and negative 122. If you can see that, great. Otherwise, go through and solve the equations. So we get that W is equal to 70 and W is equal to negative 122. Well, one of these has to be completely thrown out because you can't have negative distance. So negative 122 really doesn't make any sense. So we need to take this. Our width is 70. I'm going to leave it to you to figure out the length. So pause the video, tell me what the length is. Here's a hint. All right, let's take a look at this one. First of all, pause it, correct it, and read it. I also want you to change that to be a 46. So when does the ball touch the ground? Hint, it's 0 when the ball reaches the ground. So in order to solve this, we want to plug in 0 for h. So we're going to get 0 is equal to negative 16t squared plus 46t plus 6. So now you're going to go ahead and you are going to set up your x. You want to factor this. So negative 16 times 6 is negative 96, adding to 46. Pause your video, see if you can figure that out. I'll tell you that it's 48 and negative 2. I'm going to set up your factors for grouping. So I want you to go ahead, write that down, and group it. Okay, then I want you to figure out your answer. Which one is going to make sense when you get to two factors? Negative time doesn't make sense. So get your two factors, solve it. Tell me how many seconds it is till it reaches the ground once you've factored it. All right, this one I'm going to have you do completely on your own. Note that we're trying to figure out when the gymnast reaches the floor. Think about it. What is the height when you are on the floor? Okay, so use that equation, set up your x, get the factors. Remember, negative time doesn't make sense. So if you end up with negative time, you throw that one out and take the positive version. Remember to take your quiz once you're done.